1988 by 14, the question.
A body whose mass is 2 kg.
The mass of the body is 2 kg.
And has a volume of 500 centimeter cube.
500 cm cube. Note this one. Kilogram, centimeter. We have to convert one. Either we convert to meter cube or this one to grams. But it's easier to convert to grams. Continues.
Just float when completely immersed in a liquid.
See, just float when completely. Completely. Just float when completely immersed what?
In a liquid.
Okay.
Calculate the density of the liquid.
Next of the liquid. Now, when I say body just floats, when completely immersed, this is what we have. It means total fraction of what is inside. Nothing is outside, but it's floating and it's in. This will only happen if these two bodies they have almost same density. They are almost what? The same density. So when the body floats normally, according to the principle of flotation, the mass of the floating body equals to the density of the liquid, volume of liquid displaced. And the volume of liquid displaced is the fraction of the volume of the body immersed. In this case, everything enters, so our F is 1. So volume of liquid displaced is actually equals to what? The volume of the body. So it means mass equals to the density of liquid times volume of the body. So what is the density of liquid in this case? Mass of the body over volume of the body. Mass of the body over volume of the body is same thing as what? Density of the body. It's as though the liquid and the body are the same density. But in this, like I told you, kg, centimeter cube, we have to convert this one to grams. So for kilogram to grams, multiply by 1,000, that's what? 2,000 grams. So this becomes what? 2,000, 2,000 by what? 500. So what's density here? 4 grams per cm cube. But this is not the SI unit of density. This may not be in the option. So from gram per cm cube to kilogram per meter cube, multiply by 1,000. So this is equivalent to what? 4,000 kilogram. It is easier to convert kilograms to grams and getting density in what? Gram per cm cube than converting cm cube to meter cube. Because to convert 5,000 cm cube to meter cube, we have to divide by 10 raised to the power minus 2, that's 20, all raised to the power 3. That's 500, 10 raised to the power minus 6. That's what? 5 times 10 raised to the power minus 4. Meter cube. So that will be the volume in meter cube. So we can have the density of the liquid equals to the mass. We are now going to use 2 kg over what? 5 times 10 to the power minus 4 meter cube. So directly we are going to get what? 4,000 kilogram per meter cube. The mistake most students to make here is they believe to convert cm cube to meter cube. For example, this 500, they will only replace this c because we know centimeter actually means 10 to the power minus 2 meter cube. But the only thing they don't realize is that this cube is for both centi and meter. So we have to multiply this one also raised to the power of 3. Same thing as dividing by 1 million. So meaning to convert cm cube to meter cube, we divide by what? 1 million. Million has 6 zeros. Sorry, there's a mistake here. It's multiplied by million. This is meant to be 2 because cent means we are replacing, we are not dividing. Although the final sign is correct. This same thing as 500 centi cube meter cube. That's 500. Centi itself is 10 to the power minus 2, all this power 3 meter cube. That's what? 500 times 10 to the power minus 6 meter cube. Which in turn will give us what? 5 times 10 to the minus 4. So like I was saying here, if you want to convert directly, we are only replacing this centi, what I did here. So it's as though we are multiplying by 10 to the minus 6, or we are dividing by 1 million. Same thing. Multiplying by 10 to the minus 6, same thing as dividing by 1 million. Wait, 1989 question 12. A piece of wood
of mass 40 grams.
So the mass of the wood is 40 grams. Before we even continue the question, the wood is less dense, so most likely it will float. But continue.
And uniform cross-sectional area of 2 centimeters square.
If you are given area, it means you have to get volume.
Float upright in water.
The
The length of the wood immersed.
The length of the wood immersed is So the wood floats upright in water. Let's say this is a container, which in it we have water. So the wood floats. In this case, you are not told the fraction outside of the fraction inside. You are not told. If you are not told, so it's best you assume that the wood floats this way, that the whole part is inside. Similar to the question we saw before now. When the body floats, the mass of the body equals the density of the liquid, volume of liquid displaced. Since the body floats with all its parts inside, so the volume displaced equals the volume of the body. So let's get the volume first. The volume becomes what? Mass over density. So the mass is in gram. Are we giving density?
Density of water.
Okay, it's floating water, right? So there is the density of water. The mass is 40. The density of liquid, which is water, is 1. So the volume is what? 40 cm3. We know volume equals to area times length, height, or thickness. So volume is 40. Area is 2L. So therefore, L equals to 40 over 2. So the length equals to. So we assume that the length inside the water is what? Even if there's still some part outside, what we got is this length inside. Option. The question?
The mass of a stone is 15 grams. When completely immersed in water.
When completely immersed in water, the mass of the stone is 15 grams. So that's mass in water.
And 10 grams when completely immersed in a liquid of relative density 2.
Relative density what? It's 10 grams in the liquid.
The mass of the stone in air is.
Mass in air is. So this is very straightforward. Relative density of a liquid equals to what? Weight in air minus weight in liquid over weight in air minus weight in water. Or this time around, what was the RD 2? Each time using weight can also use mass because G will cancel. mg. So what's weight in air? That's mass in air. We are looking for it. Weight in liquid 10. Weight in water 15. You can finish it by yourself. You can multiply, you get MA minus 10 to MA minus 30. So bring 30 here, 30 minus 10 to MA minus MA. So MA equals to 20 grams. The mass in air is small. Note, all these mass are what? Apparent mass. Because mass never what? Change. So they are apparent mass. Okay, the question?
An object of mass 400 grams.
An object of mass 400 grams.
And density 600 kilograms.
Density 600 kilogram per meter cube.
It's suspended
With a string.
so that half of it is immersed in paraffin of density.
Half of it is immersed, Abi.
Yeah.
So it means volume of the liquid displaced is half of the volume of the body.
Half of it is immersed in paraffin of density 900 kilograms.
So density of that liquid now, which is paraffin, is what?
900 kilograms per meter. The tension in the string.
A body is immersed in paraffin. The weight of the body acts down, and here we have tension. This is weight in the liquid. Similar to the first one we saw, we are looking for the what? Weight in liquid, apparent weight. Archimedes principle: weight in air minus weight in liquid equals to density of the liquid, volume of liquid displaced times what? G. We are looking for WL. So WL equals to WA minus rho LVLDG. So what's WA? The original weight of the body, mg. So that's mg minus density of the liquid, volume of the liquid displaced, in this case half of the volume of the body times g. The mass of the body is 400 over 1000, 0.4 kg. 0.4, g is what? 10 minus the liquid density 900 times half of the volume of the body times g, which is 10. What volume of the body? We are not given. But we know that since density is mass over volume, volume equals to mass over. So what we have will be mass of the body over its density. The volume here, V, is mass over density. What was the mass? 0.4. Over what? Density of the body? 600. So from here, weight in liquid equals to 4 Newton minus everything here is 0.3. Weight in liquid equals to 3.7 Newton. So therefore it means the tension, sorry, is 3. So that will be 1 Newton, which is tension in the syringe. 1995 question 20. Okay.
A piece of wood floats inside water at room temperature.
A piece of wood floats inside water at room temperature.
With a fraction of it above the liquid surface.
With a fraction above the liquid surface.
As the temperature of the water is raised.
As the temperature of water is raised.
The part of the wood above the density of the liquid
Will, now look at this. Let's suppose this is a liquid in this container and we have a wood floating with some parts here. Now the temperature of the liquid is increased. So you have to know that temperature and density are inversely proportional. The more the temperature change, the lesser the density. So if the density of this liquid reduces, what happens? It means this one can enter more. If the density of the liquid reduces, what happens? So this will be able to enter more. So the fraction above will reduce. Option A.
decrease because the density of the water decreases. Temperature.
No, it will decrease it because what? Density what? Decrease. Yes, I think that's the answer. The fraction above will decrease because the density of the liquid what? Decrease. Why? When temperature increases, density decreases. A is the option. But let's continue. Option B.
Increases.
It cannot increase. C.
Decreases because the density of
It cannot increase. D.
increases because
It cannot increase. E. So that's actually A to decrease because density what? Will decrease. 1997 question 16.
a cube of size 0.1 meter actually from a
0.1 meter, right?
yes.
For a cube, if you are given the length, it means the volume is known because volume is L cube. So from here, the volume is 0.001 meter cube.
Yes.
Continue.
What is the upthrust on the cube when
We are looking for the upthrust on the cube when
totally immersed in water?
totally immersed in water. Upthrust has two formulas. Weight in air minus weight in this case, water. Or density of the liquid, water in this case, volume of water displaced times what? G. So we are going to relate this one with the last one here. The upthrust in water becomes density of water 1000 kilogram per meter cube. Volume of water displaced is the volume of the what? Body since it's totally immersed. 0.001 G is 10. The upthrust in water is 10 Newton. Option 1997 question 19. The question.
An empty 60-liter petrol tank
An empty 60-liter petrol tank
has a mass of 10 kg.
has a mass of 10 kg.
Its mass when full of fuel.
Its mass,
An empty 60-liter petrol tank
an empty 60-liter petrol tank
has a mass of 10 kg.
has a mass of 10 kg.
Its mass when full of fuel.
Now, so this is the tank alone. Its mass went full with what?
Fuel of related density 0.72 is
Relative density.
0.72
Recall, I told you, whenever we are given relative density, it's as though we are given what? The density. So it means the density of the fuel is what? 0.072 gram per cm cube. But if you notice, the mass is given in kg. So we can convert to kilograms. So it means the density of the fuel is actually times 1000. 720 kilogram. And when the density of a body equals to what? Mass over what? Over volume. Now the question is, do we know the mass of the fuel? What about the volume of the fuel? Yes, we know the volume because the fuel will fill up the empty tank, so it's 60. So, but we don't know the mass of the. But what are you actually looking for? Mass of the tank when it's what?
Filled with fuel.
So, mass of the tank with the fuel equals to the mass of the tank plus mass of the fuel. So from here, we are looking for this. So we are looking for this, and we have this from here. So we only need to know what mass of the fuel. So from here, mass of the fuel equals to the density of the fuel times volume of the fuel. What is the density of the fuel? 720. What's the volume? 60 liters. But since the density is in kilogram per meter cube, the volume must be in meter cube. So we have to convert this liter to meter cube. Now, 1,000 liters actually is 1 meter cube. Because 1 meter cube, 1 liter is 1,000 centimeter cube. What we need actually is liter to what? Meter cube. So if 1,000 liters is 1 meter cube, 60 liters will be what? Because to the volume you need, the volume of the fuel. Let's get it. From here, 6 times 1 is 60 divided by this one. 1 of the fuel equals to 60 over 1,000. So meaning from liter to meter cube divided by 1,000. So that will be 60 divided by 1,000. So this becomes this with this, this with this. That's 72 times 6 over 10. So the final answer is 43.2 kilograms. But I think for the mass of the tank plus the fuel, that's what? 10 plus. So that will be what? Option. Alternatively, I already told you, we can look for resistance of a liquid using RD bottle, relative density bottle. In that case, it will be mass of the bottle containing the liquid. In this case, the relative density of the fuel equals to mass of the tank with the fuel minus mass of the tank over mass of the tank of the fuel minus what? Mass of the fuel itself. What we are looking for is this. We have this as 0.72. We have mass of the tank as this. So, but we don't know the mass of the fuel. But we can get mass of the fuel using density equals mass per molar mass. Sorry, mass per volume. But I think this method also works. Any of the two. 1998, number 16. The question.
A solid of weight 0.6 Newton.
So the weight of the solid, which is the weight in air, original weight is 0. What?
6 Newton.
6 Newton.
It is totally in oil and water respectively.
Imagine oil and water. What happened?
If the upthrust in oil is 0.21,
Upthrust in oil is 0. What?
210 Newton. And the relative density of oil is 0.875.
0.875.
Find the upthrust in water.
Upthrust in water. The oil is a liquid. Relative density of liquids in general equals to upthrust in liquid over upthrust in water. In this question, the relative density of the oil, which is liquid, is 0.875. Upthrust in liquid is what? 0.21 over upthrust in water. In this case, upthrust in water becomes 0.21 over 0.875, and that will give us 0.24 option C. Finally, we moved to a new century. Within 1990, now we are in what? 2000. Question 4. Yeah.
When a ship sails from salt water into fresh water.
So let's say this is what? Salt water. And this is what? Fresh water. Before we even continue, note that fresh water, sorry, salt water, will have higher density than what? Fresh. Salt water will have what? Higher density than what? Because the salt inside the water is like impurity. And when impurity is added to a body, the density does what? Increases. So a ship sails from where? So let's say this is the ship. Sails from salt to fresh. Now look at this. Before we continue the question. Since salt water is denser, fresh water is less dense. When a ship sails from here to here, what happens? It will sink more. It will go down more. Why? because the density of this one is less. Now continue the question. When what? A ship sails from salt water to fresh water.
The fraction of the volume above the water surface.
The fraction above, this is the fraction above. In this case, look at the fraction. Here, look at the fraction. Does what? It will decrease. Now, option A.
A remain the same.
No.
B increase.
No.
C decrease.
C decrease. It will decrease. C is the answer.
D increase then.
C increase then. No, it will remain. It will decrease. Is that all?
Yeah.
2001.25. The question.
If a spherical metal bulb of radius 3
If
centimeters.
a spherical metal bulb of radius what?
3 centimeters.
We are given the radius of the bulb. This is what I will do. I don't need the radius. What we need is volume. So in short, we are given the volume to be what? What volume of a sphere? 4/3 by r cube. But let's continue first.
Is fully immersed in a cylinder containing water.
It's fully immersed in a cylinder. Let's suppose initially this is the level of the water. When this is immersed here, the level of water will rise. And this volume of water displaced equals to the volume of the what? Of the sphere. They'll be the same. If it's completely immersed,
And the water rises by 1 centimeter.
so from here to here is 1 centimeter. Note, volume is what? Area times, in this case, height. We are giving this height in 1 centimeter. Continue.
What's the radius of the cylinder?
What is the radius of the? We are looking for the radius of the cylinder itself. Now look at this. This increment in volume of water, this one itself, looks like a cylinder. Now look for the radius of the cylinder. But note, when a body is submerged totally in a liquid, the volume displaced is volume of the body. So this body that enters is actually a sphere. It means the volume of the sphere equals to what shape is this one? Cylinder. Volume of the cylinder. Volume of a sphere is 4/3 by r cube. Volume of a cylinder is what? Pi. We're using value for r because these two r they are different. Pi cancels pi. We are going to this radius to be what? To be 3 from here. We are looking for this big R. And this H here is what? 1. So in short, this is 4 times 3 squared.
Yes.
Why? Because this will take one of these indices. Then 4 is 2 squared times 3 squared equals to R squared. Cancel what is squared. R is 1 to 2 times 3. So the radius of the cylinder is what? 6 centimeter. Cancel. Times 3, 6. 2002 question 10. The question.
A copper cube weighs 0.25 in air.
A copper cube weighs 0.25 in air.
0.17 when completely immersed in paraffin oil.
0.17 when completely immersed in paraffin oil.
And 0.15 when completely immersed in water.
0.15 when completely immersed in water.
The ratio of upthrust in oil to upthrust in water.
The ratio of upthrust in the oil, the paraffin oil, to what?
Upthrust in water.
Is that's actually density in water. And what's the net density? Weight in air minus weight in paraffin. Weight in air minus weight in water. So what's weight in air? In paraffin, 0.17, 0.25, 0.15. From there we have what?
0.045.
Option.
Option A.
2003 question 3.
A test tube of radius 1 centimeter.
So test is cylindrical. So of radius what?
1 centimeter.
Is
Is loaded to 8.8 grams.
It's loaded to what?
8.8.
It's loaded and its mass is now 8 point what?
8 grams.
8 grams.
If it is placed upright in water,
It is placed upright in water.
find the depth to which it will sink.
Find the depth to which it will sink. So it means this cylinder is what is floating. When a body floats, the mass of water float equals to density of liquid, volume of liquid displaced. Now for this test tube, this is from the principle of flotation. When the body floats, its mass is the density of liquid, volume of liquid displaced. What's the liquid in question? Is it water? It's paraffin. It is water. So density of water. And in this case, the volume of the liquid displaced is the fraction of the volume of the body in mass, the floating body. Now, but in this case, we can directly represent the volume of liquid displaced as the volume of the test tube inside here. And since this is a cylinder, the volume displaced is going to be pi r square h. And this is h, right? It's not the full h. We don't have the full height. All we need is the height inside. That is the volume it's going to displace. So the mass of the test tube is 8.8. Density of water is 1. 22 over 7. Radius is 1 squared times h. So from here, bring the 7 here. 7 times 8.8 over 22 equals to h. So h here equals to 2.8 centimeters. 2004.34. Yeah?
The change in volume when 450.
The change in volume
When 450 kg of ice.
when 450 kg of ice, mass of ice, is completely melted is
Density of ice 900 kg.
density of ice is what? 900 kilogram per meter cube.
Density of water 1000 kg.
Density of water is 1000. Now, when ice melts and becomes water, something remains the same, which is what? The mass. Since density is mass per volume, here we can say volume equals to mass over density. So the initial volume is, let's call it V1, when it was still ice. What's the mass of the ice? 450. Density of ice, 900. And here we are going to get our V1 to be 0.5 meter cube. When the ice melts to become water, the volume of water, let's call it V2, equals to, we are seeing the same mass because the 150 grams of ice will turn to 450 grams of water. Over what is the mass of water? 1000. So from here, our V2 becomes what? 0.45 meter cube. What you notice? The volume decreases because the density what? Increases. Density of ice increased from 900 to 1000. Normally, water is liquid, ice is solid. We expect that normally ice will be denser than what? Water. But it is opposite. Due to the anomalous vapor of water, density increases when the ice turns to what? Water. So we are looking for change in volume, which is V2 minus V1, which is what? 0.45 minus what? 0.5 rather. Sorry, V1 minus V2. 0.5 minus 0.45. And that's what? 0. Option